Hello everyone, this is Om from Team 5795 and I'm going to be doing a video discussing the differences between the main 3D printing filaments that you'll see on commercial markets. Now this video will mainly be going over the physical properties of the various filaments as well as the pros and cons so you can decide which one you want to use on your next print when you're building your robot. Now let's go over some of the main properties that we'll talk about. First we have the thermoplastic and thermoset filaments. Most plastics will be thermoplastic when it comes to 3D printing. Thermoplastic filaments can be melted down without losing their structural integrity, while thermoset filaments tend to lose the integrity when reheated. Injection temperatures are the optimal operating temperature ranges for the nozzle of the 3D printer, and those are usually higher than the melting point of the filament itself. Next, we have the flexural strength of a material. Now, the flexural strength is a material's resistance to deformation. And deformation is usually going to be, dense, weakened parts, and the higher the flexural strength, the more resistant it is towards those deformations. However, some materials tend to be brittle if their flexural strength is really high, and we'll get to that in one of the next slides. Now, for reference, when you're looking at the flexural strength of these filaments, understand that the flexural strength of aluminum, which is the standard material for a lot of FTC parts, is around 43,000 pounds per square inch. Now let's get to our first filament. Here we have PLA plastic. Now PLA is one of the most common commercial filaments for FDM printing. It's produced to be easily broken down. That means it's biodegradable and easily degrades in heat, which means it has lower operating temperatures than other filaments because it's easy to melt. It is a thermoplastic filament, and its heat threshold for softening is 110 to 150 degrees Fahrenheit. The filament will also soften if it's facing constant warm temperatures, such as if you leave it out in the car during a hot summer day. And these softening temperatures are something to look out for. If your print is going to be facing a lot of heat, then it can weaken if it's made out of PLA, and you're going to be aware of that. Now, the injection temperatures tend to range from 350 to 460 degrees Fahrenheit. And the good thing about PLA is that it's very easy to use, and you don't have to worry about having to mess around with a lot of settings such as speed and temperature. Put it in the general range, and it should work, and you might have to do some minor tweaks. One of the issues with PLA is that it's very brittle when compared to other filaments such as ABS and PETG. If you take a strand of PLA filament and bend it back and forth, you don't need to do much for it to eventually snap. And because it's resistant to deformation, it is brittle. It has a pretty high flexural strength for a lot of filaments at 12,000 psi. And the price for a PLA filament is around $20 per kilogram, which is standard for most of the filaments. Now, onto our next filament, which is ABS plastic. Now, ABS is another common commercial filament, but it's not just used in 3D printing. It has a lot of commercial household uses. A lot of plastic products that aren't handling consumables like drinks and foods tend to be made of ABS. A lot of office supplies are made of ABS. Kids' toys are made of ABS as well. Now, it is a thermoplastic filament with a high resistance to heat and deformation, higher than PLA, with its softening thresholds ranging from 176 to 230 degrees Fahrenheit. And now, the injection temperatures and the operating temperatures for ABS tend to range from 410 to 482 degrees. The issue with ABS plastic is that it's very sensitive, and you need to find the exact temperatures and speed and settings that work for your printer, or else instead of getting a messed up print, you won't get a good print at all, where the layering won't work in the way you want it to. So instead of warping or being loose, it doesn't layer at all and creates this spaghetti strand mess of plastic. So you need to make sure that when you use ABS, you have to find the correct settings that work for your printer. That being said, ABS is less resistant to deformation, but it's more flexible than PLA. So it's a good thing for a lot of prints, because unless prints are taking direct hits like bumping into things or taking a lot of stress in the sense that it's being hit, you don't have to worry about much. But if it's taking stress like weight, then it's more flexible and it can handle that kind of stress better than PLA, with its flexural strength being around 8,600 pounds per square inch, and the price being the standard price of $20 per kilogram. Now, let's go on to our third filament, which is PETG. PETG filament is known to have a combination of the pros of ABS and PLA. Aside from 3D printing, PETG is largely used in non-commercial operations, such as packaging and manufacturing, so you probably won't see it that much in your house. PETG is a thermoplastic filament with the heat resistance similar to ABS. Its threshold for softening is 140 to 176 degrees, with its injection temperatures ranging from 445 to 480 degrees Fahrenheit. Now, if you look back at ABS, you'll see that the injection temperature range is wider for ABS than it is for PETG, but PETG doesn't have the same problem as ABS where you have to worry about meeting the exact temperature settings, the exact speed settings on your printer compared to ABS. It's much easier to use, much like PLA. But it does have the durability of ABS plastic at a flexural strength of 11,500 psi for a lot of filaments, which is closer to PLA, but not as brittle, and again, it meets a standard price. And our final filament that we will be talking about that's mainly useful in FIRST Robotics and FTC Robotics is TPU plastic. TPU plastic is unlike the previous filaments as it's notably soft and flexible with very little structural support. TPU is commonly found in kitchen containers such as the Tupperware. If you find Tupperware lids, they're very flexible and they're a little soft. That's generally the consistency of TPU filament, mainstream TPU filament, as there are variations that can be rigid. Now, it is called thermoplastic polyurethane, which means it is thermoplastic. It has heat threshold of around 176 degrees, with the injection temperatures ranging from 420 to 480 degrees Fahrenheit. TPU filament is an elastic polymer, and its elasticity is very dependent on the print settings. If you have a print with high infill and wide layering, then it's going to be a little more rigid compared to a more hollow print that has thin layers. And because it's so flexible, it's very resistant to deformation at a flexural strength of 14,000 psi, and it is a little bit more expensive at $25 to $30 per kilogram. Now, if TPU plastic isn't as structurally supportive as other filaments, then what would be the use for this? Well, one of the most common uses that TPU plastic can have in robotics is to print custom flywheels. Flywheels tend to be soft, and while some may be rigid, they're not necessarily hard. They do have a lot of support though. And so you can get those variations by changing the print settings on your print. And if you get custom flywheels, then you can have them perform the exact operation you want. For example, if we look back at the previous season of Ultimate Gold, we were picking up and launching discs, and flywheels were very common in most designs. So having custom flywheels means that you could get the exact properties you want into your crucial elements. So this is what TPU plastic can be used for, and it is the most common plastic for these kinds of applications, especially in 3D printing. So, now that you guys have seen the basic properties of the various filaments, compared the various filaments, and seen how they operate in a 3D printer, you should have a better idea of how to use them, which ones to use, and whether you want to change your filament into another variation to make sure that you get the best print possible for your next 3D printing operation. And once the robotic season starts, you know which print you need to make sure your robot can perform the best it can at the competitions. Thanks guys, this is Owen from Team 5795, and hope you guys have a great day. Don't forget to like and subscribe, and also check out our Instagram. See you guys.